I've been on a break. I went on holidays. I've been taking it easy. I went to Greece, to an island called Crete for a week, and did some other stuff just to relax. So, I'm just kind of seeing if my brain is still working at this point. Maybe you're in a similar situation. Maybe you've had a bit of a break and you're coming back to studies and you're a bit worried that your head is just full of fluff and nothing else. And so let's just have a go at a problem, just to get ourselves back into it. And also, it's not, let's not jump in the deep end. Let's not just start off with the really hard stuff, because that can be really demotivating. So I thought I'd just have kind of a fairly easygoing problem here. This problem is from a Toomua paper. If you're not sure what Toomua is, I'll be going through that in an upcoming video. What else? Oh, well, this is an AS level kind of, not just a bit above GCSEs, so year 12 kind of problem. So if you are in GCSEs, then this will be pretty challenging, but let's just jump straight in, shall we? So the question says, find the complete set of values for x for which x plus 4, x plus 3, 1 take x is greater than 0, and x plus 2, x take 2 is less than 0. And we have 7 choices here. Okay, so where to start? It's tempting, especially if you're like me and your head is feeling a bit fluffy, to go, oh, well, let's divide by these factors here. So, if we divide everything by x plus 3 and 1 take x, we would have x, greater than -4. This is a mistake, because these factors can be negative, so it's it's a little bit more complicated than this. I would suggest just using your graph sketching skills here, because given that these polynomials or these expressions are already factorized for you, sketching those graphs is actually pretty straightforward. So this is a cubic with 3 factors, therefore 3 roots. It's also going to be a negative cubic. Another way to write this expression here would be x plus 4, x plus 3, and we could factorize that -1 out, and we get x take 1 greater than 0. So this is, maybe it just makes it a little bit easier to see that the roots are -4, -3, and +1. And it's a negative cubic, so it goes like this. That's something you learn in your graph sketching, the shape of the cubic, given it's a negative or positive cubic. So let's just do a quick sketch, and then we'll do the quadratic as well, and then we'll see, just from those sketches, what the solutions are. So the roots are at -4, -3, and +1 for this cubic, and it's a negative cubic, so it goes like this. And we want where this cubic is greater than 0. So that's over here, where it is less than -4. And, there we go. And it's greater than 0 between -3 and 1 in here. Okay, let's sketch the quadratic. So that has roots at -2 and 2. Again, these are skills you learn in graph sketching. If you've done that already, maybe you're in year 13, you would have learned that in year 12. If you haven't learned that yet, then that's something to look forward to. So these roots are at -2 and 2, just reading from those factors, and this quadratic is less than 0 between those 2 roots. So in here. Okay, so now we just need the overlap between these 2 graphs, and all we need to do is just look at the graphs and identify where that overlap is. So we have some overlap between -2, because this graph does not is not below 0, anywhere other than between -2 and 2. So we can't go past that to -3. Maybe I should have drawn, well, we can draw the 2 graphs on the same graph. Maybe that would have made more sense. So we just need to see where that overlap is, where the cubic is greater than 0 and where the quadratic is less than 0. And it's clearly between -2 and 1, right? That's where that overlap is. Okay, so the answer is B for that one. Okay, good start, I think. Hopefully that got some of the fluff out of our ears and a little bit of a warm up. And in the next one, maybe we can tackle something more challenging. All right, thanks for watching. I'll see you in the next one. Bye for now.